Okay, so we're going over binomial distribution, which is this formula here. And it's going to help us calculate your chances of winning prizes in a form of lottery. So let's say it's even Tim Hortons or some coffee place. You have a 20% chance of winning when you roll up the rim for something, okay? And let's say you're going to play this game 10 times, right? So we buy 10 cups of coffee, we win 10 times. We want to know what our probability, so this is our probability, of winning at least 7 times, okay? So this is actually very important because at least 7 wins gives us many different options. This formula will help us calculate for one specific one. So for instance, if we're trying to figure out what's a probability of winning 7 out of 10 times, okay, we'll do that as the very first one. Now, our n here, in this case, because we're going to play the game 10 times, n will be 10, okay? X stands for our number of successes, okay? Number of success. Well, in this case, we're talking about 7, so X will be our 7 in this case. And the rest of the things we just kind of fill into our formula. Oh, sorry, we also got to figure out probability. Our probability of success, that's what P stands for. So P is probability of success. And in this case, that's 20%. And Q is actually probability of failure. Okay? Probability of failure, which is essentially 1 subtract P. So if P is 20% or 0.2, what is our probability of failure in this case?
0.8.
Yeah, exactly. We just subtracted from 1. Good. So let's put this into our formula here. The probability of this event is such that we have 10 trials, right? So it's a 10 combination. We want to win 7 times, multiplied by our probability of success, which in this case is 0.2, and we will expect to have 7 successes, multiplied by the probability of failure, and we expect to have how many failures? Well, what that means is 10 subtract 7, which would be what? Yeah, so we could rewrite this as really just saying expected to have 3 failures in this case. Okay, so it's the exact same formula. So I'll write it all out in one step here. So do you want to calculate that combination for us? 10C7, 0.2 to the 7th times 0.8 to the 5th.
120.
So the combination is 120. Okay.
2 to the power of 7 is 0.00000128.
8. And then probability of failure.
8 to the power of 3 is 0.512.
Great. And then all we have to do is multiply all these numbers together.
1, what was it? 2.5?
Yeah.
2.5.
Oh, 2.8, I think, sorry. Oops.
2.8 times 0.522. I had a big decimal.
You did? Okay, so let's do this all in one shot. Another way you could rewrite this is 0.2 is the same as 2 divided by 10, right? To the power of 7 multiplied by, I'll put in brackets, 8 divided by 10, okay, to the power of 3. Oh, shoot, I did that in the wrong order. Okay, let's just do it this way. 0.2 to the power of 7 times bracket 0.8 to the power of 3 and bracket equals, and then times 120. Is that what you got? 3 decimal places and 7?
Yeah.
00732, is it?
000786.
That looks like, is that what we got? Okay, so
3 zeros.
good. Yeah, you're right. 3 zeros. Okay, so extremely small number. In fact, as a percentage, it's actually 0.07%, like not even close to 1% of chance winning. Now, that's only of winning 7 out of 10 times. This says at least 7 out of 10 times, which means we're going to have to take these probabilities. So here's one of our answers. And we're going to actually have to add it to the probability of winning 8 times, which we'll have to recalculate. And I'll quickly write the formula. So here's 8 wins, which is going to be 10C8, 0.2 to the 8th, 0.8 to the 2, okay, plus the probability of winning 9 times, okay, and it's really rare to win 9 times because you only have a 20% chance. That's why these decimals are so small. Like, if you only have a 20% chance, to win 7 times is huge. You should really only be winning maybe 2 out of the 10 times. So to win 7 is a very small decimal. To win 8 will be even smaller. To win 9, same idea. We have 10 trials, 9 successes. Our probability of winning is 0.2 with 9 successes times 0.8 with 1 success. And finally, the idea of 10 wins. So winning every single time, what's our probability? It'll be extremely rare. It'll be 10C10, 0.2 to the power of 10, and 0.8 to the 0. So we have to add all of these probabilities together. Now, with a good calculator, we can do this all in one shot. I'm going to do the 8 here. So 10 combination 8 times 0.2 to the power of 8 times 0.8 to the power of 2. So we got a very small decimal again, 0.1234428. And if we look at it, it's actually really similar to our last one. We've just increased by 1 decimal place. Okay, let's try the next one. 10 combination 9, I know you can't see it on here, times 0.2 to the power of 9 times 0.8. Okay, this one's even smaller, 0.1254. And then finally, the last one, 10C10, I believe, is 1. Yeah, so really, and 0.8 to the power of 0 is 1. So this is 1 times 0.2 to the power of 10 times 1 again. So 0.2 to the power of 10, extremely small decimal. So 3, 4, 5, 6. We need to, all of the ones that we're just highlighting here, all of these values, hope I typed that other one in right. Oh shoot, I didn't even, oh no, I did write it down. All of the values we've highlighted, we have to add them all together. Okay, so I can try that on here. Let's assume we've done this right. So that was our first one, plus point, and there's 4 zeros, 1, 2, 3, 4, 7, 3, 2, 8, plus point, how many zeros? 1, 2, 3, 4, 5 zeros. 4, 5, plus, and we have 1, 2, 3, 6. This number's not even really matter. 1, 2. All it really did was look at a 0.08% chance. So, in the end, you have the zeros were what? 4 zeros and then an 8, right? So it was approximately 0.8. So you have a 0.08% chance of winning 7 or more times in this lotto, which makes sense. It's really rare. You only have a 20% chance of actually winning in this case.